I'm Charlie. This video is about encounter question and take a answer of the assessment tube. Um, the first problem we encountered was to improve project activity. Basically, we used a data directory in a huge test field, counting about a few million words, but the field was available from the Gutenberg project, Wiktionary, and British National Corpus's collection of books, as the corpus clearly shows that the results are not satisfactory for us. Therefore, we end the Gutenberg corpus to the natural language process to calculate based on the previous version. The second question is how to deal with the correction of uncommon words. In fact, a word set stores the number of times each word appears in the corpus. But one problem is what to do if you encountered a new word that we have never seen before. If a word is spelling correctly, but the word is not included in the corpus, the word will never appear in the training set. In fact, there are many standard ways to solve this problem. We choose one of the easier methods, assumed that a new word have never happened once, because we set the probability distribution to 0 to a small probability value.
Hi, this is Wenjie Jiang. I'm going to talk about one of our challenge and how do we solve the problem. The problem is, when given a word W, how can I eliminate all possible correct spellings? In fact, the predecessor have studied very well. This is a concept of editing distance. Editing distance between two words, defined as the use of insertion, deletion, transposition, substitution to from another word. Let me explain a little bit about insertion. Insertion is insert a single letter to a word, and the deletion is delete a single letter. Transposition is exchange two adjacent letters. Substitution is change one letter to another. And then the spelling checking program claims that around 80 to 95% of spelling errors are within editing distance of 1. However, when we experiment with 270 misspelled compounds, we found that only 76% of misspellings belonged to a set with an editing distance of 1. So we start thinking about editing those words with a distance of 2. However, we have a new problem. When we use the editing distance of 2, the running time of the program becomes very long. We find that it is because each time the generate word is checked whether it is in the known word set. This process takes a lot of time. Therefore, we use Python's set operations to perform in intersection operations with the generate word set, which greatly improves the effectiveness of the program. And last, let's talk about some possible improvements. There are two problems that cause the final misidentification. Identification. One of the most serious factors in the unknown word. The second factor that can lead to an error is that both words appear in our dictionary, but the one with the highest probability of our selection is not what the user wants. And then the second question is the priority order of the candidate word so far. So far, we have used a very simple model. The shorter the distance, the greater the probability. And then the last one is when we correct words, we don't consider the relationship between the two words. And then